Supervised learning is a subfield of machine learning, and it's defined by its use of labeled datasets to train algorithms to classify data or predict outcomes accurately. Supervised learning helps organizations solve a variety of real-world problems, such as classifying spam emails in a separate folder from your inbox. In a nutshell, supervised learning uses a training dataset to teach models how to provide the desired output, also called labels. The algorithm measures its accuracy by adjusting itself until the error between the input and the desired output has been sufficiently minimized. The prediction step comes next with the trained model. New unseen data from the test set is provided, and the model does its best to find an appropriate label. Supervised learning can be separated into two main types of problems: classification and regression. Classification uses an algorithm to accurately assign test data into specific categories such as true or false, admitted or not admitted, and spam or not spam. Regression is commonly used to make projections such as for sales revenue, expected salary, or housing prices. Various algorithms and computation techniques are used in supervised machine learning processes. Some of the most commonly used learning methods are neural networks, linear regression, logistic regression, k-nearest neighbor, and support vector machine. Also, supervised learning models can be used to build and advance a number of applications, include image and object recognition, speech recognition, and customer sentiment analysis. What about unsupervised learning? Unsupervised learning is also a subfield of machine learning and uses algorithms to analyze and cluster unlabeled datasets. How does that work then? These algorithms discover hidden patterns or data groupings without the need for human intervention. Unsupervised learning models are used for three main tasks: clustering, association, and dimensionality reduction. Clustering is a technique for grouping unlabeled data based on their similarities or differences. Association uses different rules to find relationships between variables and a given dataset. These methods are frequently used for recommendation engines along the lines of customers who bought this item also bought this one. Dimensionality reduction is a learning technique used when the number of features or dimensions in a given dataset is too high. It reduces the number of data inputs to a manageable size while also preserving data integrity. Various algorithms and computation techniques are used in the field of unsupervised machine learning processes. Some of the most commonly used learning methods are k-means clustering, a priori algorithms, and principal component analysis. The ability to find similarities and differences in information makes it the ideal solution for anomaly detection, image recognition, customer segmentation, and recommendation engines. While unsupervised learning has many benefits, some challenges can occur when it allows machine learning models to execute without any human intervention. Some of these challenges can include computational complexity due to a high volume of training data, longer training times, higher risk of inaccurate results, and a lack of transparency into the basis on which data was clustered.